Hi friends, welcome to our lesson. I'm Mrs. Gridney, and today in our lesson, we'll be using different protractors to distinguish angle measure from length measurement. So in other words, we'll be able to tell the difference between the two. Here's what you'll need for our lesson today. Let's get started. Let's start by doing some folding of your two circles. Pause the video and fold each of your circles in half and then in half again, just like we were making a right angle template. Then open up both of your circles and trace the perpendicular lines. When you're done, come on back and we'll continue. Welcome back. Now let's label the larger circle, circle A, and the smaller one, circle B. How many angles and what kind of angles do you see at the center of each of the circles? There are 4 right angles at the center of each of the circles. So then, does the size of the circle impact the number or the size of the angles? No, both circles, the smaller one and the larger one, have 4 right angles at their center. Interesting. And what's the measure of a right angle? 90 degrees. Let's take our dark marker now and draw an arc on circle A and on circle B. Now use your finger and trace each arc. Which circle has a longer arc? Circle A has a longer arc. But wait a minute. Don't both arcs measure 90 degrees? Why are their arcs different lengths? Maybe you're thinking, well, circle A is larger, so maybe it needs a larger arc. Or maybe you're thinking, you just don't know. Well, let's dig in and figure it out. How many total degrees in this circle? 360 degrees. And how many total degrees in this circle? Also 360 degrees. If we divided each circle into 360 degrees, each arc length in circle A would be a little longer than the arc lengths in circle B. Here, I'm still measuring a quarter turn in each circle, and each arc is 1/4 of the total distance around the circle. Think of it like this. This string goes all the way around circle A. Watch. So it represents a 360-degree arc. And this string goes all the way around circle B. Watch. Again, representing a 360-degree arc. Now, if we take these strings and stretch them out to see how long they are, we can see how long the arc for circle A is. It's so long it goes off the screen. And here's the arc for circle B. Now, if I were to chop up each of these strings into 360 equal-sized pieces, which arc would have smaller pieces? Right, the arc for circle B would have smaller pieces. So 90 degrees is 1/4 of 360 degrees. I'm going to cut each string into 4 equal parts. So here is circle A's string, and I'll cut it into 4 equal parts. Here are the 4 equal parts from circle A's string and circle B's string now. Here are the 4 equal parts from circle B's string. Notice that one of the parts from circle A's string is the same length as the arc from circle A, and one of the parts from circle B's string is the same length as the arc from circle B. Now, which arc is longer? The arc from circle A is longer. So, does the length of an arc determine the measure of a given angle? Pause the video and explain what you're thinking. Hopefully you said no. We could have longer arcs or shorter arcs, but they could be measuring the same size angle. We just have to remember that no matter how big that arc is, it's still part of 360 degrees. We can have a really tiny circle with really short arcs or a really big circle with really long arcs, but a right angle will still always measure 90 degrees. Let's place circle B on top of circle A now to prove that the length of an arc does not determine the degree measure. Look, those angles match. Way to go. Now let's take a look at angles C and D from your practice sheets. What kind of angles do you see? Right, they're both acute angles. And what do you notice about the arc length in each angle? Maybe you noticed that the arc length in angle C is longer than the arc length in angle D. It looks almost like angle C came from a larger circle than what angle D came from. Or maybe you were thinking that even though the arc lengths are different, it still looks like the angles might be the same size. Well, let's measure to see if each angle turns the same number of degrees. Do you remember what the tool is called that we use to measure angles? Right, it's a protractor. Take a look at this protractor. What do you notice about this protractor? Well, it certainly looks different than the protractor we used in the last lesson, right? The protractor that we used in our last lesson was shaped like a full circle, and it went all the way up to 360 degrees. This protractor looks like half of a circle, and it only goes up to 180 degrees. This protractor also has a straight edge. Great observations. Just like we measured angles with a circular protractor, we can measure angles with our 180-degree protractor. Now, protractors sometimes have two sets of numbers on them. We can see a set of numbers here on the outside and a set of numbers here on the inside. What do you notice about these two sets of numbers? Did you notice that for the outside numbers, they start at 0 on this side and go around to 180 degrees over here? And for the numbers on the inside, they start at 0 over here, even though the 0 isn't labeled, and go around to 180 degrees over here. We determine which number to read based on the side of the angle that touches 0. So let's use our 180-degree protractor to measure angle C. To measure with this type of protractor, we first have to align this middle notch, see that notch there, with the vertex of the angle. So here's the vertex of angle C where the two sides meet, and I'm going to align that with the notch in the center. There we go. And then we have to align the 0 line or the baseline on the protractor with one of the sides of the angles. So I'm going to line that up. And then finally, we just read the number that aligns with the second side of the angle. Okay, so I'm going to go around second side of the angle. Here it is. Angle C measures 60 degrees. No, wait, 120 degrees. Which is it? What do you think? Oh, right. This angle couldn't measure 120 degrees. It's an acute angle. That wouldn't make sense. So in choosing between these two numbers, we know angle C measures 60 degrees. We could also know, because remember, we count up from the side of the angle that touches 0. So we would count up from this side. If we were reading 120 degrees, then that would mean we counted backwards from 180. And that doesn't make sense. Now pause the video and use your protractor to measure angle D. Remember to align the vertex with that middle notch, align one of the sides of the angle with the 0 line or the baseline, and then read the number that the second side touches. Remember to think about if the angle measure that you got makes sense. When you get back, we'll discuss it. So what's the angle measure of angle D? It's 60 degrees. Wow, the angle measure for angle D is equal to angle C. The arc lengths are different, but the degrees are the same. So what do you think would happen if we put the angles on top of each other? Let's try it. I'm going to take this page protector and I'm going to trace over angle D and then put it on top of angle C. And let's see what happens. What do you notice? It matches up. The angles are the same size. Look at these different protractors. What do you notice? Well, this one is a 360-degree protractor, and these two are 180-degree protractors. They all have two sets of numbers, and they're all different sizes. Let's align our protractors using the center point like we did with our two circles at the beginning of the lesson. Do you see how all the protractors have different sized arcs? Some are smaller, some are larger, but they all measure the same degrees. Notice the tick marks on all the different protractors. Some are really close together, like on this one. Why are the tick marks so much closer together on this protractor? Well, it's the smallest protractor, so that means the arc lengths are shorter than on the other protractors, but they still measure the same degrees. Now, let's use all three different protractors to measure angle E on your practice sheet. But first, make a prediction. What do you think the measure will be? Let me hear what you think. I was thinking angle E will measure more than 90 degrees because I can see it's an obtuse angle, and I'm going to keep that in mind while I'm measuring. So pause the video now and measure angle E using whatever protractors you have. And when you're done, come on back and we'll compare. Welcome back. So what did you get as the measure of angle E? I measured using all three protractors, and they all showed that angle E measured 130 degrees. So then, what does that tell you about the side lengths of an angle? The side lengths can be any length, and it won't impact the size of the angle. If I measure with this small protractor, and the side length was only this long, the angle would still measure 130 degrees. If I measured with the larger protractor, and the side length was longer, if it was this long, the angle would still measure 130 degrees. So the side length doesn't impact the size of the angle. Let's look at problem 1A on the problem set together now. Use whatever protractor you'd like to measure the angle that's shown. Are you all noticing, like I am, that the sides of the angle aren't long enough to reach the numbers on the protractor? So what can we do? Oh, that's right. We just learned that the side length of the angle doesn't change the angle measure. So we can just extend the segments on the angle until they're long enough to reach the numbers so that we can use the protractor to measure. Let's do that. Now, let's see if I can measure. Now I can measure, and the angle measures 36 degrees. Excellent work today, friends. I think we're ready for the problem set. On the screen are the must-do problems. Work on these problems for 10 minutes